Welcome. Let's dig into the Earth a little bit deeply here. I've got here a map of the Earth, and every single little red dot you see is an earthquake that's happened in the last 100 years. And there are some earthquakes that are kind of scattered around, but most of them, if you take a look, line up. Here is a great example of earthquakes that line up really well. Here's another one. Here they're a little bit more scattered, but they start lining up here again, and they line up here and here. It's almost like they're showing us something about the Earth's surface. And in fact, they're showing us that the crust of the Earth is broken into pieces. And every place that there's an earthquake is really showing us something at the edge of one of those pieces. So you see around Africa, you've got this line that lines up pretty much around the entire outline and then into the ocean a little bit. But this is a piece of the Earth's crust. And that piece is called a tectonic plate. And there's several tectonic plates that the crust is broken into. And the edge of it here, where all these earthquakes are, that's called a plate boundary. And there's a lot of things that happen at the plate boundaries that we'll look into this week and next week. Now, this is a map of the earthquakes, and clearly, earthquakes tend to happen at plate boundaries, at the edges of tectonic plates. Here is a map of volcanoes, and you'll see it's got those same plates labeled, except for now the boundaries are shown in black. But take a look at the volcanoes. Again, there's a couple in the middle of a plate, but almost all of them are at the boundaries of the tectonic plates. And so there's got to be something going on there. So in this lesson, you'll start off by reading a little bit about the tectonic plates. And I love this diagram because this shows you the crust and the mantle that we've been talking about. But there's another way we describe the top part of the Earth that's just the solid part, because the mantle, parts of it can be a little bit squishy, but the top part is really solid. So if you take a look at this top part of the mantle, just this little part right here, and then the crust above it, these two parts together we call the lithosphere. It's hard and brittle, and it can be broken, kind of like the shell on an egg. Have you ever had an eggshell kind of crack all over into pieces? That's what's happened with the lithosphere of the Earth. All right. And basically, the theory of plate tectonics is the theory that the Earth's crust is, and what lithosphere is broken into all these pieces, that these pieces move around, which kind of tells you why the continents move around from last week. And it connects to Alfred Wegener. And it explains how a lot of things form at the boundaries, like earthquakes, volcanoes, mountain ranges, and so on. So you'll read a little bit about it, you'll answer a few questions here, and then here's a fun interactive right here. This is where you're going to take a map of the Earth, and you're going to figure out where these plates go. Like here's the Pacific plates. Ooh, looks like the Pacific plate might fit in right there. Make sure you complete all of this before moving on. All right. Now you'll start reading about plate boundaries and the different things that can happen there. If these represent pieces of the lithosphere, if these represent different tectonic plates, there's really three ways they can move. The first way they can move is towards each other like this. Then they can move away from each other like this. And then they can also move sideways past each other. And your job is to model these three motions in this interactive right here. So you'll actually grab one of the two plates and either move it towards the other one or away from it or sideways. Watch what happens if I move it towards the other one. Oh, you see something happening, and it's got labels, it's got an animation, and it's got a little thing to read down here. Now you're going to want to take notes in this section right here about what happens. Now, when they move towards each other, it's called a convergent boundary. It looks like there's definitely volcanoes here, and it says that there's plenty of earthquakes. Now, you'll read about this for all three motions. You'll have to do that 3 times. Okay, so you'll take notes here, and then you'll use those notes to fill out this chart when they're moving towards each other or away from each other or passing side by side. What's the type of plate boundary, which is written right here? Does it create earthquakes? And does it create volcanoes? It's not going to be yes for everything. So write yes or no, but make sure it's based on that model. We'll learn about the 2 different types of crust because that really matters at the boundary in terms of what it can form, whether it forms mountain ranges or ocean trenches or new oceanic basin, which is just the bottom of the ocean. If you take a look, this blue right here in the diagram represents the ocean. So underneath the ocean, you have the oceanic crust. Look how skinny that is compared to the continental crust. This is on land, on the continents, and it's really thick. This is underneath the ocean. This is oceanic crust. It's really thin. And it's really dense, really heavy for the amount of stuff that it is. So when two plates are colliding, if one of them sinks, it's always going to be oceanic crust because it's much more dense. All right. The continental crust is really, it's not dense enough to sink ever. It will always float. So you answer these questions right here. And then you've got a reflection question. And then we'll really dive into the 3 types of boundaries next week. But don't forget, this week you have 2 additional assignments. They're both linked in the other style. One is a Google form assignment on feedback on style that you'll have to open up one of your old assignments and look at some of my feedback. And the other one is going to be a reflection on Wednesday's Dragon Crew launch. So make sure that you are tuning in on Wednesday, and then after that launch happens, we'll open up that link so that you can write your reflection. All right, thanks guys.